And so today, Jerry will begin with a story of his, and then we'll have various other distinguished speakers to continue with the discussion. Okay, Jerry, it's all yours right now.
All right, if I can figure out how to do it. All right, we'll now see if this clicker has the range that they claimed so that I can actually see what I'm talking about. All right, this is the beginning, as it says. And first, we have the family album before we get down to the serious stuff. And we'll talk about now before we travel off into the distant past. All right, so here is the Gang of Five, coined by Hagen at the Sakurai award ceremony. If you'll notice, this is on the, that's Kibble, that's Hagen. You see, I've been fortunate to be surrounded by giants. And the picture, unfortunately, Peter Higgs couldn't make the ceremony. There was a massive snowstorm in Washington, D.C. It caved in part of the roof of the hotel we were in, but apparently it was fixed. It was in the bar. Apparently it was fixed by the time we got there. To give you some idea of the snow, there is Kibble standing in the snow, watching with amusement. This is outside my son's house, who's also a physicist. He works in D.C. Well, there I am, and Hagen, and my son, trying to figure out how we're going to get the car out, which Hagen forgot to put coolant in because it was winter. All right, so it is appropriate before I go to the past, I think, to show an interesting clip from Angels and Demons, and Jim Baird has assured me this is legal. So,
unfortunately, I'm not a lawyer.
Where is that camera, number 86?
It's wireless. It too was stolen. It could be anywhere inside the vacuum.
That canister contains an extremely combustible substance called antimatter. We need to locate it immediately or evacuate Vatican City.
I'm quite familiar with the incendiaries, Miss Vetra. I've never heard of antimatter being used as such.
Well, it's never been generated in significant quantities before. It's a way of studying the origins of the universe, to try to isolate what some people call the God particle, but there are implications for energy research.
God particle?
What we call it isn't important. It's what gives all matter mass, the thing without which we could not exist.
You're talking about the moment of creation.
Yes, you're what I am.
Now you know why the LHC blew up. So, what Victoria, the young lady in the picture, well, she didn't think that it matters what it's called. Respectfully, at least three, and I suspect all the Gang of Five, think that maybe a name change would be in order. And an example was said at the April meeting by Robert Drosser, who gave apparently a name from a Icelandic volcano, but which is pronounced the Beck particle. The G is silent, as I often am, as Chunny knows. And it has the advantage of reflecting all the authors that have some claim to this, and it's in the order that the papers appeared in Fitzroy Letters. It might stick, at least at Rochester and IC, I'm not sure about here, but at least in Rochester, as you can see, they have a colloquium going on soon, which uses the name. But in any event, we'll use it here once back. And now let's travel back half a century to the beginning of this thing. It's hard to believe so long ago. Okay. Let me start at Imperial College in London, because this was where the work was done. And there, this distinguished looking gentleman is Abdus Salam. He was a powerful, powerful intellect, a very, very interesting man. He started the group at Imperial College in 1956. He very soon bought in Kibble in 59. You can see there's Kibble as a young man. And they Salam was, for a long time, interested in the description of particle interactions through gauge theories. And in fact, a student of his essentially invented Yang-Mills theory, but it was never published. It's in his thesis. And Salam worked for a long time with his collaborator, Ward, trying to produce a unified theory of weak and electromagnetic interactions. And they thought very early in the game they could do it by breaking symmetries, but because of Jeffrey Goldstone's theorem, they at least in their initial efforts, did not succeed. Salam did succeed later on after sitting down and talking with Kibble and got a Nobel Prize for his work. Now, meanwhile, at Harvard and MIT, you saw those serious guys. Meanwhile, this is Lord May of Oxford, the guy on the left, I think giving a friendly signal. The guy sitting at that Sunbeam Alpine, which I think was powered by a tractor engine, is me, and there's Hagen there. At that time, as you can see, I was not worried about problems of mass. I thought if there was a boson, certainly it would be light. But, so now let me shift on to the main talk. I've given you the fun parts. Let me talk a little bit about what physics was like in the 60s. Many of the tools that we use now were there, if not heavily used, or in the state of development, particularly the Schwinger action principle, which most of you younger people have probably never heard of. The Feynman path integral, they're both essentially the same thing. Close to the same thing. There was group theory. There was about the time that I went to IC in '64, there was a realization that that group theory, in particular SU3, was probably a very good way to describe particle phenomenology. They had the makings of flavor SU3. It all fit together when the omega minus was discovered. But as far as calculations in quantum field theory, things were very, very primitive. To the leading approximation, the approximation was perturbation theory. And of course, renormalization theory had been worked out by that time. In fact, that's where Salam, along with Matthews, had gotten a good deal of their reputation, in particular by understanding overlapping divergences, or beginning to understand them. And Nambu was beginning to do very important, very interesting things. He introduced a version of Kern algebra, essentially invented it, I think. And then he launched the study of spontaneous symmetry breaking through his work on the BCS, and in particular the relativistic Nambu-Yamamoto model, which is, as you see from the interaction, is made up of 4 fermion interactions in such a way that it has a chiral invariance, or apparently does. However, he insisted that this interaction term would introduce a mass for a normally massless free fermion.